In this video, we'll be looking at how to complete Venn diagrams using a given set of data, and how to read and use Venn diagrams and their notations to calculate a probability. Before watching this video, I'd recommend that you've watched the Probability Foundations video to ensure you understand the logic behind probabilities and their calculation. Venn diagrams tend to be made of two or more circles held within a rectangle to represent sets within an entire diagram. Reading Venn diagrams can very much depend on being able to understand the notation that is used, and most of it is quite simple and straightforward. Let's start with the E symbol that appears in the top corner of the diagrams. This stands for the universal or entire set. In effect, it stands for every number or object that is used within the diagram, whether it belongs in a group or not. So the diagram could be shaded as follows to show what it encompasses. Next, we can see how the sets are notated. If we are told it will be in set A, for instance, this would be anything contained within the circle that is labelled A, and would be shaded like this. It includes this section that is also in B, but as it's still part of A, it's included. Next, we'll see how the complement symbol is used, which looks like an apostrophe. This refers to anything that is not in set A, and can be shaded as follows. This means that even though something is in this section for B, it cannot be included in this group as it's still inside of group A. Here, we see one of the most used symbols that occurs with Venn diagrams. It's called the intersect symbol. And if we were to use this in the context of this diagram, we'd say A intersect B. We'd shade this area here for this. You may notice it looks rather like an N, like the middle of the word and. So I always refer to it as meaning anything in A and B. It has to satisfy the criteria for both sets. Next, another symbol which is used a great deal in Venn diagrams, this is called the union symbol. If we use this in the context of this diagram, for instance A union B, we would shade the diagram to include the following. I often refer to this as the OR symbol. So include everything in A or B. It can be included in either group where it just has to satisfy the requirements for either set. Let's look at how we use these instructions and notation to answer some questions. In this first question, we are shown this Venn diagram, where people have been asked which ice cream flavour they prefer, and their choice has been recorded and placed in the Venn diagram. It seems that 26 prefer chocolate, 39 prefer vanilla, 12 couldn't decide between them and said they liked them both. There are 3 people who stated that neither chocolate nor vanilla was their favourite, and they're recorded in the bottom right hand corner. We're asked to calculate how many people were asked in the survey, so we add all the numbers up together. We'll get 26 plus 12 plus 39 plus 3 to equal 80, so the survey includes 80 people and their responses. We're then asked if someone was chosen at random, what is the probability they liked both vanilla and chocolate? This could be shown as the notation of the probability of A intersect B, which includes 12 people out of a total group of 80. So we can say the probability is 12 out of 80 they would like both. Let's look at how you can use a Venn diagram to help you work out how to categorize a set of data. In this question, we're told that out of 100 people surveyed whilst shopping at a pet food store, 45 people have a cat, 60 people have a dog, and 11 don't have a pet. It's often easy to confuse whether to use a Venn diagram or a two-way table to organise this type of data. A simple way to decide is whether there is overlapping choices. If we add all these responses together, we get 116 people. But the question states that only 100 people were included in the survey. The only possible solution is that some people must have both a cat and a dog. The way to work out how many is to look at how many over the total surveyed the numerical total is. In this case, there are 16 more responses than there are people in the survey, so 16 must have both a cat and a dog. And they'll go in the intersection. This is the reason we'll use a Venn diagram. If 16 have both, then 45 minus 16 will give us 29 that just have a cat. 60 minus 16 will give us 44, and this can go in the just dog set. Let's not forget that 11 people did not own a pet. We'll put those in the bottom corner. We've now represented all 100 people in the Venn diagram. We're asked the probability of choosing someone that only has a cat, or the possibility of cat. As there are 29 people with just a cat, we can say the probability is 29 over 100. Let's look at a more complicated Venn diagram with more than two sets. In this question, we're asked to complete a Venn diagram from the results of a survey completed by David on 100 people on what sandwiches people liked out of the options of tuna, egg, or chicken. We're given the following information. 7 people liked all 3 sandwiches, 10 people liked tuna and egg, 16 people liked egg and chicken, and 19 people liked tuna and chicken. 38 people in total liked egg, 44 people in total liked chicken, and 46 people in total liked tuna. We're then asked to answer the question of how many didn't like any of the types of sandwiches. Let's start by thinking where we can place the information we're given. Firstly, 7 liked all 3 sandwiches, so we can add that in first to the very centre of the diagram. If 10 people liked tuna and egg, we need to take the 7 that liked all 3 into account, so we can subtract 7 from 10 and get 3. To place this into the section for tuna and egg, but not chicken. 16 like egg and chicken, so we subtract 7 who are in the centre to get 9 who like egg and chicken but not tuna. As 19 people like tuna and chicken, we can do the same and get 12 who like only tuna and chicken but not egg. We're told that 38 people liked egg, and we know how many others liked egg and the other sandwiches, and we can subtract them from the total of 38. 3 plus 7 plus 9 equals 19. So 38 subtract 19 will leave us with 19 who only like egg and can be placed here. If 44 like chicken, we can add 12 plus 7 plus 9 to get 28 and subtract it from 44 to get 16 who only like chicken. If 46 like tuna, we can add 12 plus 7 plus 3 to get 22 and then subtract that from 46 to get 24 who only like tuna. Now we need to add all these together to check who we've included and who isn't yet accounted for. When we add 24 plus 3 plus 7 plus 12 plus 19 plus 9 plus 16, it equals 90. So there are 10 people who don't like any of these options. As we are asked how many people didn't like any of the options of the sandwiches given, we can state that the answer is 10 of them. In this video, we reviewed how to complete Venn diagrams using a given set of data and using the notation to calculate probabilities. In the final video of this course, we'll be looking at exam strategies and revision techniques. I'll see you then.